this nut. Let's continue with our control structures. And again, start with the basic one. Of course, everybody's favorite while loop, right? So you want to do something on some conditions, right? So, so what issues are? So, do we test this condition before, right? Or as I call it, shoot first and ask later, do while loop, right? So also, how do you initialize the control variable, right? Is it explicit, right? In C style for loop, right? External to the loop, right? Maybe there's implicit initialization, right? For for loops in many modern languages, like in Python, the variable automatically is initialized, right? So also, it's going to be control, it's going to be a counter, right? Or are we going to do some logic, right? So also, another issue is scope, right? Scope of your loop variables, meaning what do you do with the variables, for counter or like for variables, right? After the loop is finished, right? Do they persist or not? Again, depends on the language. And again, the thing is, body, can a loop body have multiple statements without delimiters, for example, right? Without block. Flexibility, right? Can you modify the variable outside? This could be, of course, errors. So how about exit? Do you allow break, right? Some languages don't actually allow break. Famously, Scala didn't have good break, right? Again, and of course, iteration based, which is if you have some sort of sequence of data, right? You want, of course, this type of syntax is very convenient, right? So what do we do with nested loops? Do we allow them, right? And also, are there any constraints? Like how are you going to break out of loops, right? If you have triple nested loop, generally the inner break, right, will go into break out of the inner loop, right? That's what you used to, right? So again, do you allow it, right? And right. So Fortran had the counters, right? I'll go into the while loop. C popularized the three-part for loop, right? Again, before C, they didn't really have this such a simple thing, right? So I wonder if Python was the first to allow this regular for loops for collections. So again, we could do technically everything with the while loop. I mean, technically we go back to goto and comparison, we could do everything with those. But as humans, hopefully, right? We want something that's readable, and also not only readable, but also less error prone. So in this regard, Python's for loop approach, right, is, somebody's calling me again, just 1 second. Second. All right. Now, so we got to the rich loop constructs, right? So iterative branching, right? So do loop, right? Do and continue, right? So, right. And again, remember early Fortran, just like basic, you had these number counters, right? Do 100, right? So, so loop from the do, right? You do something here, right? And then you have continue, command continues. So begin, look at this here, right? This is algol syntax. If you take Pascal, it looks kind of like Pascal already because Pascal took inspiration, right? Again in the late 60s. So the begin and end, they didn't have curly braces. They had not. I guess maybe the computers didn't have curly braces. I don't know. The standard committee, writing begin and end. I think some people like it. I personally don't really like this way of writing because this begin and end does not seem does not seem so, I think it's just too wordy, in my opinion, but of course, this is how it is done. Of course, so C, because so this familiar C type of syntax, of course, right, is for loops, right, and of course, or while loops, do while as well, right. So, it would be interesting to see if Kenny can find, did anybody else, was there this iterator, which Python has, right, this type of iterator, was this actually invented by Python or was somebody else? I wonder if there was, if I want to ask maybe an LM for this, right? Was there any language before? Maybe Smalltalk or something else? I would not be surprised if some experimental language had this, right? Very nice, right? Very nice this approach, which now every, most modern language have taken this approach, right? And you have some sort of sequence of data on, of course, what we gain with this approach, we don't worry about out of index errors, right? Getting off by one error. You are guaranteed to go through everything, right? So again, the philosophy, which I always teach, is while loops. When do we use while loops? When?
we have a condition.
Yes, and we don't know exactly when it's going to end, right? On these more than four loops, we use for loops when we have a specific determined amount of things to do, right? 10 or we know there's going to be some sequence, some data, right?
This way for Python, it's a for each.
Yeah, it's for each, right? Again.
So it doesn't seem really like something that Python didn't. Right?
But no, the thing is, but for each JavaScript for each is very much later. Python's 1990, right? So I was saying, is there any language in 1980s, right, which had this type of iteration, sequence of iterator without index, right? Because vast majority will be C-type loops, right, with index, right? So the sequence, it's a syntactic sugar, really, but it's still this approach. I wonder if there's this for each type of loop is available earlier. I wouldn't, maybe, I don't know, maybe Ada, probably not, right? Be interesting to see if you can find a language which had before Python.
Well, apparently Java had.
But Java doesn't count, 95. Right? Java did this later, like I said. Python 1990, so you find me something from 80s or 70s. If you find me, I'll be glad to add it here, right? Extra task, right? So Scala, of course, has some interesting loops, right? For, again, right, until there's some, for example, Scala, which is a very experimental language, it has some really cool things, lots of language inspired by it, but also maybe does too much, right? It includes two types of loops, right? Until and to. And for example, since I haven't done Scala for maybe half a year or so, I now forget which one includes, which doesn't. So until includes and to does not include, right? So to me, my English until 10, automatically I don't associate that this is inclusion until, right? Until 10. Well, I guess, yeah, I guess if you think about, until means you include that item, right? But to, you don't include it, right? Very subtle difference, right? Very subtle difference. Is it needed? I don't think it's needed, right? Because you'll mess up, right? So while loops, of course, regular. So Kotlin, right? You'll do Kotlin in a few weeks, right? For I in 0 until 10. So again, you can see how it's inspired from Scala loops, right? Very heavily inspired, right? So until means it includes it, right? For I in until, there's other iterations. So Go, of course, is famous for only having a for loop, right? A couple of you have done Go already, right?
Yes.
It only has for loop. It doesn't have while loop, right? So
Well, it kind of has
yeah, you fake it. Yeah, I mean you can use it. You can put in, it's kind of 2 for price of 1, basically, right? There's a while loop instead of for loop, basically, right? So because again, you don't need all three. You can use basically this one here, right? You only need this one, right? Then it's while loop, right?
Yeah.
Yeah. Okay. So yeah. So this one here, right? You see, that's a while loop in Go, right?
That's the thing I don't like about Go.
Yeah.
Their loops are.
Yeah, but the thing is, the thing is, what they did is, so they made these people actually. One of the guys invented C, right? Like 30 years before, and he started working at Google, right? A gray beard and all that, and he wanted a really simple language, basically, for people. For all these Java and Python programmers who had to, so they don't have to learn C++ and, break things too badly, right? So they made language. Go is basically meant to be a language you learn like a week or two and start working immediately, basically, right? So, but there's number of things I don't like about Go, but again, we'll get to that later. But so Go is interesting in this regard. Okay, so iterables, we don't need that anymore, right? It's all already good stuff, right? and right, while loop, right, all that stuff. Yeah, based on data structures, right. So conditional branching, right? Yeah. So this is here's the go to statement, right? Go to 22. Look at this, right? This is an example of spaghetti code. This is a good example, right? Pi in Fortran, right? So you have start if, right here. Oh, so number 3 means where you jump back. You see this, and this is really hard. Let me open up this a little bit bigger. Oh, come on. Let me show this in a open. Can I see? Can I make this? Oh, can I? Oh no, no. Sorry, too much zoom. Too much zooming. I don't know if you can see this, right? So it's interesting, right? So how it's tricky, right? It calculates, I think, pi, but look at all these go statements. And some of them, what's really hard is that the if includes the go to statement. The if something, the first one is 7, right? So it goes to 7. Otherwise, it goes to 7, 11, right? So it goes 7 is if 1 and 11 if you continue. Really annoying, I think. So you have this big sheet of paper and you're jumping around, right? Right. So go to is I think harmful in this case indeed. So write and you go to 23. Yeah, you write that. Right. So it would be very hard to exactly make sense of what's happening here. It looks like certainly it looks like there's some sort of testing. There's some variables, some 98, some 100, some 90. You know, yeah, not really. This is from book, like 60-year-old book actually, right? So, not fun, right? So, scope, right? And again, when you're doing unconditional branching, what's another issue is you lose scope possibly, right? I mean, this means you have variables should be global. If you have a full unrestricted goto, right? It means if you jump to some other area of code and you have no reference to some variables, I mean, that's gonna be some problems, right? So, and the thing is, was the early people, there are people who are like, yeah, we want goto in our code. They said that this is gonna be efficient code, right? Now, these days, nobody argues for that because our compilers, you know, are efficient and already even interpreters, right? The goto would just would harm things, right? Also, like I said, the only exception is error handling if you don't have a language like C, which does not have a regular error handling, right? So sometimes, right? So exception handling, right? Right. So Fortran, yeah, this is of course example of conditional branching, right? In BASIC, again, you guys all survived fine without BASIC, right? This was a regular thing in 80s, 90s, right? Yeah, this book here, you probably have not read this one. This is a famous book in Latvian, right? This is, but you don't have to worry about it anymore. That's good. So yeah, so I mentioned this already. There is a label. So this guy here is a code. If you want to use goto in C, there it is, right? You have labels, right? You can jump, basically, right? So this you could write your C-like Fortran, which is not, this would not be a good target. But here I'll show you, I mentioned this already, how Linus uses goto, right? This is how Linus does it, right? He is quite a decent programmer, you know, understatement. He's a great programmer, right? So, so this is how he uses it, right? But this is because he has special needs, right? He doesn't have really any extra libraries, right? So, basically, he has labels, right? And if there is, right? So this is so this approach here, right? Go to error 1, get error 2. So this is how if you didn't have errors, right, he would have to write this code. And this, I think, this is a case where you can undo things, right? So left side is if you said, okay, you are prohibited from doing goto, right? And I think triple level nested ifs are harder to read, and this code is much cleaner, right? Flat ifs make your code much nicer. Look at this here. So these three go to inside some function, right? Inside the Linux kernel function, right? So you fix it, right? And you return something, right? Error 1, right? You immediately do. So because they're different levels, it translates really nicely to to this type of error handling. Again, just because of limitations of C, right? Maybe again, maybe you disagree. Maybe you think the left side's easier to read, right?
No, that's better.
No, I think right side's better too, right? So this is the exception that proves the rule that goto, So this is a way where goto is nice, right? Leads to nice clean code. So in C, right? So this is what you want to would like to do, right? Because again, instead we would do some exceptions in other languages, right, or something else, right? So yeah. So yeah, go to yeah, Python. I don't know. I never seen the go to. Let me see. This actually I mentioned this. I seen this library. It's really weird. Like Python go to library Python library with go to. I want to see this. Yeah, exception. Yeah, you can do exceptions, right? No, thank heavens. Somebody said, no, don't do that, right? But there was a library of something weird, right? Yeah. Some people are really used to it, right? I've seen some people who are like, older C programmers who really wanted Goto in Python. I don't think there was one, but I think there was some weird library which kind of faked the Goto. Oh, here. PyGoto. Yeah, he did some magic, right? The jump instruction. I think this guy here was, let's take a look. On Goto. Where was the link? GitHub. Let's check this one here. Is still around. This is a joke, but still applied, right? Install PyGoto, right? We flag Goto 3, right? So see how this works. Go 3, where? Where is this 3? Where does this 3 come in? Go to 7. What does that mean? That's a line. 1, 2, 3, 4, 5, 6, 7. I don't know. So 0 if flag. Not flag. Let's see. If flag, go to 3. Flag is not.
Oh, yeah, the 3 is the line.
Oh yeah, it's a line number. Okay. So yeah, kind of funny. Let me answer this. Yeah, this is, let me get it. So go to, yeah, it basically what it is, because it's underneath there's some, the go to, Python has a line handling function basically, right? You can introspect your code in Python. So that's what he does, I believe, right? So should you do this? This is completely for fun, right? I'm not gonna advise you to do it. So let me see if we can figure this code. So why does it print 001? Let me see.
Because, it's when it starts from the top,
Yeah.
it's false, then flag is true, then it prints the first 0.
Oh, you're right.
Yeah, then the code within the if statement,
Yes.
it goes back to the third line, and
Yes.
flag is again false, it prints again the 0.
Yes, of course. It just switches the flag around. Okay, yeah, right. So here, so 1, 2, 3, 4, 5, 6. Yeah, this is basically a break. Yeah, this is like break here, of course. That's what you would sane people would use break here, right?
Now in the for loop it would be disgusting.
Yeah, this is disgusting stuff. Don't do it, right? Yeah, don't do this. Let me add the link with earning, right? So where's my Python library with Go, which simulates Goto in Python. There you go. Do not use it in production. Yeah, I'm not saying it's bad, right? So yeah, Java of course skipped it, but of course break and continue, helps a lot, right? Of course exceptions, right? So of course assembly will have, right? Assembly is kind of hard to imagine without goto, right? So Pascal specifically did not have. So one more thing, I think, and we're almost finished. So with Dijkstra again, this guy, the guy who really hated goto, right? He had this idea of guarded commands, and they have not really taken off, right? So basically, guard, right, is true, right? It's kind of like if, right? So there are guards, right? So you have guard, right? So basically, it's like if something's work, right? So it seems very simple, right? But I guess syntactic sugar, right? So also you can select them together, right? So only one of the commands whose guard is going to be true will be executed, right? If multiple, right? So idea was that also you could have multiple commands, maybe choose one of them, which kind of seems weird, right? So, right. So, so his idea was that you introduce non-determinism. What does this mean? Meaning you don't really know in synchronized programming, right? Concurrent programming also, right? So you're doing you have multiple processes happening in your machine, like most all of your computers doing that right now, right? It's by its nature non-det it looks non-deterministic, meaning you don't know which process on which core is running, right? And so there are, you know, there are no guarantees which process will run on a specific core. You could set that the core, right, and which one will run first, right? You have like 10 parallel processes, right? And they might run in different, different order. Eventually, eventually they all finish running, right? And you have a finished program. But this is very hard to do. Introduce lots of race conditions. Again, talking about parallel programming, very hard to track down bugs. You have multiple parallel process debugging is very hard. So Dijkstra's idea, this is 1970s by the way, was to have these guards, right? And also the idea that this will be non-deterministic, that we hit these guards. Right, so here's the idea. You have P and Q, right? Two processes, right? P can enter, critical session, right? So this is again, right? But they can't do it, right? Right. So if you have flags, right, you could set it like this. This can enter a critical section, right? So, but they are not directly, these guard commands are not directly seen in modern languages, right? Sort of indirectly, right? Well, what else? What else? What else? So unconditional goto, simplicity, high level of constructs. Maybe did we miss any other statements here? Oh, exception handling. We can talk about that a little bit, right? So it is indeed a form of control structure, right? Because you try something, right, and you transfer the control to a different branch, right? So so you have the try catch finally, right? You try something within a try block, right? You catch something, except depends on language, right? And also you have finally, right, which works after the whole thing has finished, right? Yeah. So it is basically a way of branching, really, if you think about it, right? So but now we have an extra problem is propagation, right? If you don't catch the error, what happens? It propagates, right? It goes up the stack, basically onto the function stack, right? And hopefully finds something which catches you, right? And if no function catches it, right, usually end up with a crash, right? Of course, right? Uncaught exception error, right? Something like that, right? That would be applied, I think, in C++, in Java, probably in Python too, right? So, well, if you propagate, right? So this is again. Sometimes you don't. By the way, one of the core issues is you don't. If you try and do error handling, what should you do? You should not handle errors. Don't just discard errors, right? Meaning, you handle the errors you are prepared to handle. Meaning, you have, let's say, you are writing, error input handling function or something, right? You can handle your input, bad errors with the input, for example, with exceptions, and that's your task. But you don't handle like something else happening, some other exceptions, right? Those should be handled by something up, right? So the scope, right? So the cleanup, of course, cleanup is kind of messy. Also, do you allow handling multiple catches, right? Catch one error, catch different error, maybe multiple exceptions, right? So it kind of like switch case, if you think about it, right? Just with an error function. So maybe let me show you. I can show you example. Maybe we have like a few more minutes, right? So let me show you example of code. Example of handling input with try except in Python, right? Right. Enter number. User input, right? And then of course we all know, right? Yeah. You all know love this, right? It's a value error, right? Yeah, right. And then we could do this, right? So, so this would be with using. So remember again, let me do a little bit bigger, right? That what's the issue? So this will print only if there is no error, right? So transfers. So it is possible user enters, then control will be transferred to accept block, right? And we can handle error. Importantly, the line below will not be accessed, right? So that's a key part, right? See, yeah, right, yeah. And we can do, result, result equals, right? Yeah. So this is safe. So this is safe to do, right? So we'll run, right? And, oh yeah, I need to enter number, right? I'll put all this, right? Did not enter number, right? And of course I enter 77, and I get the, right? It works. Okay. So alternative, right? So why I'm showing you this? So alternatively, we could use if else. But it is not as nice in Python to handle user input, right? So yeah, so if user input, right, and if, and I don't think it will work, right? If user input is digit, right? So this would work, right? Also, right? Yeah. Yeah. And then we can cast, right? So this is the alternative approach. Else, yeah. So this is the alternative approach. And this, I would say, in some language, this is the only way you do it. You have to do some. You have to implement some checking function, right? So, in some languages, you would have to write your own is-digit function, right? Right. So this is less common, right? Again, while this right won't work, how about 88, 99, it works, right? Yeah. Okay. So which approach do you prefer? Result is roughly basically you can do the same thing. What do you think? Yeah. Yeah. In fact, I'm saying in Pythonic, right? Again, this is just Python specific. This is much more common, and also because it's much more flexible. Because you, first of all, you don't have to worry about these type of functions, right? You let the exceptions handle it, right? Which one? Go. Yeah. Yeah. But you end up in Go you have to handle. It's like you have to handle all these errors all the time, right? It's like non-stop error handling, right?
Sometimes it can be tedious, but it's much more understandable.
Yeah. So in a way, yeah. So we'll see this again. So that's a main complaint about Go. You have to handle errors all the time, but it also leads hopefully to safer code. That's the heck.
Complain and benefit at the same time.
Yes. And again, reminder. This famously C++ guy said there are two types of languages, right? The ones everyone complains about, and the other languages that nobody uses them, right? So if you complain about some language, most likely this means language is popular enough to be used, right? So people don't really complain about Pascal much anymore because they're not using Pascal anymore, right? Or so if people complain about some language, it means it's actually it's useful, right? Doesn't mean it's no language is perfect, right? Okay, let's finish this. And so visual, yeah. So we go back to the beginning of this when I showed you this, right? The flow charts. But this is not of course not the flow chart, but the idea was that from the very beginning you could draw these flow charts. I mean which would visualize your flow of your code, right? So. In fact, like I said, and so this led to this visual programming style, right? So I think it's really not quickly it becomes not so useful. Maybe for very simple things, right? But you have a huge setup. I mean, look at this here, right? It's not really that much easier than just a big bunch of spaghetti. I mean, sometimes yes, mostly for teaching, yes. right? So they're very limited, I think, right? So how do you understand this control structure? If you have a really, you end up inheriting a mess, maybe it's your own mess, right? But most likely somebody else's mess. What do? Right, you can of course do the pseudocode. IDEs are great these days. They offer the code folding indentation, really nice, syntax coloring, of course. There's also a bunch of things like source code visualization tools. They will try to visualize. I used to have a coworker who he had the misfortune getting a really complicated program, and he actually did print. He had this whole like wall. He had a wall of office just with one of his printout basically, right? And I remember he like went, oh, that's there, right? He trace his finger over there, right? So anyone use these type of printouts for visualization tools? Like
Kind of printout.
it measures code to flow. I forgot which ones. There are a bunch of them, right? So meaning they print out your function calls, what's happening, basically, like a dependency diagram. Maybe I'll show you some examples.
Like that. Can make diagrams, but not printed them out.
Yeah. Okay. Yeah. Right. So scope, right? So block level structure. Okay, I think that is it, right? No. So I'll see you guys on Monday at 2:00 sharp, right? Yeah. I mean, you can come in later if you want. I mean, all right?
Historically, that's come later.
Yes. All right. You know,